All right, hello everybody. We're going to go ahead and get started on topic 1.2, which is going to be terrestrial biomes. So a couple things you need to take away from these biome lectures include A, what is a biome? B, what are the major terrestrial biomes, which are land biomes? And then how do the location of these land biomes result in different natural capital throughout the world? So if you don't remember from the middle school days, a biome is essentially a community of organisms that are adapted to a specific climate in their area. Now, when we look at land biomes or terrestrial biomes, the main two characteristics that are going to dictate organism adaptation is going to be what is the precipitation in that area and what is the temperature. The reason we focus on these so much when it comes to land biomes is because that's going to dictate your productivity, i.e. how much photosynthesis is going on, and then also your biodiversity. So the more plants you have, the more photosynthesis you have, that's going to support a diverse food web and many different organisms to flourish in that biome. Whereas lower temperature and precipitation leads to low productivity and lower biodiversity. So here we have two terrestrial biomes, two biomes that are on land. One is a rainforest that has really high rain, really high temperatures year long, resulting in a very diverse and productive ecosystem. While over here we have a tundra, where temperatures tend to be very low and precipitation tends to be much lower as well. So we have a lot less biodiversity. We have a lot of organisms like grasses and mosses, but it doesn't get too much more complex than that. So as I said before, precipitation and temperature are going to be the main things we look at for terrestrial biomes. And how we graph these is something called a climograph. Now you'll notice that this looks like a standard bar and line graph that's kind of blended into one image. But if you look here, we have two y-axes. And on these y-axes, we are going to measure both the monthly temperature, but also the average precipitation throughout the year. So we have all 12 months down here. We have our temperature and precipitation on each y-axis, and we're going to graph this. Now, typically, precipitation is done through the bar graph, while the temperature will be done through lines. So you can kind of look at both of them. Students do get this mixed up a lot because a lot of times they'll use the lines to look at precipitation or the bars to look at temperature. So please make sure you're looking at your key or your legend so that way you don't mess that up. But essentially what this does is it gives us a snapshot into what a biome looks like throughout the year. So here, this is a climograph for southeast Nebraska, and we can see that they have a dry and wet season because precipitation is low, it heavily increases and then drops again, and they also have a, hot and cold season as well. So you can kind of get a good look at what their climate looks like overall throughout the year using these climographs. Now, the major biomes are going to be classified by that precipitation and temperature that we talked about. And these are some of the major biomes here. We'll go into more detail later. But typically, forests are going to have the highest precipitation, while grasslands have somewhat seasonal, and desert being the lowest. We can also categorize forest grasslands by their temperature as well. Again, we'll get into that a little bit later. We can look at things a little closer. Latitude is also going to determine biome location because being close to things like the equator, so I can find the equator here, the tropical region, so 0 degrees north, 0 degrees north and then 30 degrees north and south, you're going to have much warmer temperatures because the equator tends to be the warmest part of the earth. So we have things like tropical rainforests and tropical grasslands like savannas, and then as you work your way northward, those forests and those grasslands are going to change because there's less temperature and less precipitation available for organisms to grow there. So you can kind of use these two charts as a way to visualize those changes in precipitation and temperature and how that impacts the type of biome that we'll see there. The last thing that could really impact biome and where they are is going to be elevation. The higher you get in elevation, the colder it's going to be. Therefore, you're going to start switching biomes. So you can see here we have the Rocky Mountains. And you can see different biomes as you work your way upward. So here at the bottom, we have a nice grassland prairie, and then you have a temperate seasonal forest into a coniferous forest until finally you have a tundra. So biomes will also change based on elevation, but again, that's because elevation is affecting the temperature of that region. Now, the last thing that's also going to determine your biome is whether or not it is coastal. So oceans have a very unique property in that they have high specific heat, in that they warm up and cool down very slowly. So what they work as is kind of a moderator for climates. So if you have a really warm area, the water that is near it is going to warm up slower, therefore giving you a nice cool sea breeze. While if you have a colder area, that sea is also going to cool down slower. So it's going to give you a nice warm air breeze. So these coastal regions tend to be much more moderate as it applies to temperature. We can see an example here. We have two desert locations, one that is more inland and one that is closer to the coast. And if we compare the climate graphs of the two, what we notice is that the one that is closer to the coast tends to have not only higher precipitation, because it's near the water, but its temperatures tend to fluctuate much less. So the temperatures here will only fluctuate about 10 degrees per day, while we look at the desert here, 10 degrees throughout the year, while the desert here tends to have much lower precipitation and tends to fluctuate a little bit more. Okay? So let's go ahead and get into the major biomes that you need to know. We can divide these biomes into three major categories. We have forests, we have grasslands, and then we have the kind of unique ones that are based on the local geography. So the first ones we're going to talk about are forests. Forests are biomes that have relatively high precipitation throughout the year in order to support the tree biomass. Trees obviously have lots of biomass, lots of weight, and therefore you're going to need a lot of rain to support that. If you have a forest that is near the equator, we call it a tropical rainforest. So some of the major characteristics of tropical rainforests is they tend to have low nutrients due to high competition. And this also has the highest terrestrial biodiversity, because on average it has the highest temperature and precipitation. Here are some human impacts as well. I'm not overly concerned that you know these yet. We'll talk about these in later units, but they kind of foreshadow what we're going to be talking about later going forward. Next, we have temperate forests. These are regions that are located between the poles and the equator. So, for example, Michigan is about halfway up at about 45 degrees north, and so this is going to be a temperate forest. Now, how it differs from a tropical forest is that it has seasonal temperatures. So its vegetation has adapted to that by shedding its leaves during the wintertime. Again, feel free to read through these human impacts going forward. And then we have boreal forests. These are forests that are located in colder regions. Some of the major characteristics I want you to know is that boreal forests, like Canada or Russia, tend to have more acidic soils. This is due to the fact that they have coniferous trees, like pine trees, and those pines essentially erode and degrade into the soil, giving it an acidic type. Now, organisms that are here, things like blueberry bushes and other fruit bushes, tend to be adapted to this acidic soil. Now, the second major group of biomes are going to be grasslands. Grasslands are known for their seasonal precipitation. So if you have rain part of the year and a dry season in the other half, you're going to be categorized as a grassland terrestrial biome. If you have a grassland that is near the equator, we refer to it as a savanna. So think of like Lion King, so you have things like lions and elephants and giraffes. Some of the major characteristics, like I said, wet and dry season. Also highly dependent on seasonal fires, because when all that plant matter dries up, the grass tends to catch on fire, but that's good because it essentially recycles nutrients back into the soils. The temperate grassland, think of like Kansas and Nebraska, central US. This is grasslands that have not only seasonal rains, but they also have seasonal temperatures. Typically, these grasslands are heavy in grazers, and they play a major part in the recycling of nutrients in that area. And then finally, you have polar grasslands. These are grasslands located in polar regions. Typically, one of the major characteristics you see about these is something called permafrost. This is the idea that the soils are frozen year long due to those low temperatures. And this has got some positive and negative to go with it, and we'll talk about it more in Unit 9. Also, these have very short growing seasons because most of the year it's too cold to get any type of real vegetation growth here. Oh, sorry. Lastly, the last part of the terrestrial biomes, this is due to geography things. First is the desert. Desert has the lowest biodiversity due to a complete lack of precipitation in the area. And this lack of precipitation means it has poorly developed soils, therefore has lower plant life, and therefore lower biomass and biodiversity overall. Typically, these are found in very specific regions, 30 degrees north and south, and also on the dry side of mountains, and we'll talk more about that in Unit 4. But deserts are in very specific areas for that reason. Next, we have temperate rainforests. Temperate rainforests are just regular temperate forests, so think again like Michigan, those middle latitudes, but they are located on coastal regions. So they get extra precipitation, which means they have higher biodiversity, more photosynthesis going on overall, so therefore tend to have much more plant life. And then finally, you have shrublands. And shrublands are deserts, so think of these deserts here, that are located on coastal regions, increasing the amount of precipitation that is occurring. So if we go back to our graph here, here we have a shrubland, it's just a continuation of this desert, but because this is located on the coast, it has much higher precipitation throughout the year, and therefore can support much more biodiversity and organisms in that area. Okay. All right, so that's going to be it for today. Just a couple of things before you head out. Please make sure that you understand these major characteristics. Maybe one human impact per biome is enough for now, but we're going to get into much more detail on this going forward. You'll find that a lot of the biomes tend to have very similar impacts. So for example, forests tend to have deforestation, while grasslands tend to have overgrazing, and these are kind of a mixture of different ones as well. That's where we'll leave it for today. Um, However, at the end of every note, there's also going to be an FRQ practice. So here I have an FRQ, which is a free response questions. These will be on exams going forward. And these are just 3 questions that you should be familiar with before the end of this lecture. So if you want to give this a shot, go ahead and we can cover this in class tomorrow.